This video discusses applications of quadratics. Our first application says a sprinkler rotates 360 degrees to water a circular region. If the total area watered is approximately 2,000 square yards, determine the radius of the region. The radius is the length of the stream of water. We'll round our answer to the nearest yard. So right away, what we should get out of this application is that our sprinkler is watering a circular region, and they also give us the total area of that circular region. Therefore, we're discussing the area of a circle. Our area formula for a circle is pi r squared. They've given us the total area, 2,000 yards, so we'll substitute that in for our A. Pi is just a number, so we're not going to substitute anything in for that. You don't want to write 3.14 because 3.14 is an approximation, and if we start approximating on our first move, our answer is going to end up being less accurate than it should be. So we're just going to keep the pi symbol, and when we plug it into our calculator, we'll hit the pi key. R represents the radius of the region. Well, that's what we're trying to find, so that variable is going to stay as well. Now we're solving the equation 2,000 equals pi r squared, solving for r. Notice that in this equation we have a constant on the left side and a quadratic term on the right side. The easiest technique to solve a quadratic equation that has a quadratic term and a constant term but no linear term is square root property. What we need to do before we can apply square root property is isolate the variable being squared. So let's divide both sides by pi. Again, we're not going to type this into our calculator at this point. We're just going to keep the fraction 2,000 divided by pi. That's equal to r squared. Now that we've isolated the r squared, we're ready for square root property. When we take the square root of both sides, on the right, the square and the square root cancel out, leaving us with just r. And on the left, we're going to have plus or minus the square root of 2,000 divided by pi. So we've gotten through the algebra. Since this is an application problem, we need to make sure that our answer makes sense for the context of the application. We need to make sure that we've answered the question, and lastly, be sure to include any necessary units. So we've solved for r. Think about what r represents. R is the radius of the region. Right now, we have both a positive and a negative answer for r. Well, the radius cannot be a negative number. It can only be a positive number. So we're going to throw out the negative and keep just the positive. That's going to give us r equals the square root of 2,000 over pi. Next, we want to make sure that we've answered the question. The question is, determine the radius, which we've done since we found r, and it also says round to the nearest yard. So now we're ready to plug this into our calculator. When we plug this into our calculator, we get 25.231325. The directions told us to round to the nearest yard. So that'll be 25. And lastly, we need to include our unit, which is yards. We get the answer, r equals 25 yards. Let's take a look at another application. The original plans for Jennifer's house called for a square foundation. After increasing one side by 30 feet and decreasing the other by 10 feet, the area of the new rectangular foundation was 2,100 square feet. What was the area of the original foundation? I would definitely start by drawing a picture. The original foundation is a square. They did not tell us the length or the width of this square. It's unknown to us, so we're going to label the side with a variable. Since it's a square, we know that all sides are the same, so I'm going to label both the length and the width of our original foundation with the variable x. Now Jennifer changed her mind. She changed the foundation of her house to a rectangle. And she did so by increasing one side by 30 and decreasing the other side by 10. Since our original sides were x, when we increase one side by 30, that side becomes x plus 30. And decreasing the other side by 10, well, we started with x, and now we're going to decrease it by 10. That other side becomes x minus 10. The application tells us that after the change was made, the area of the rectangular foundation was 2,100 square feet. So we're going to be using our area of a rectangle formula. Area of a rectangle is length times width. We know that the area is 2,100. We know the length to be x plus 30 and the width to be x minus 10. Now we need to solve this equation. We'll start by multiplying out the right-hand side. That'll be x squared minus 10x plus 30x minus 300. Combining like terms, we get 2,100 equals x squared plus 20x minus 300. We see that we have a quadratic equation that has a quadratic term, a linear term, and a constant. Since there's a linear term, that rules out our ability to use square root property. I personally prefer to either factor or use quadratic formula for my solving technique. For either of those techniques, our equation needs to be set equal to 0. So let's subtract 2,100 from both sides. That gives us x squared plus 20x minus 2,400. This equation factors nicely into x plus 60 times x minus 40. And now we set each one of our factors equal to 0 and solve. This gives us x equals negative 60 and x equals positive 40. Since this is an application problem, we need to make sure that our answers make sense for the context of the application. Think about what x represented. If we turn our attention to the diagram, x represented the length and the width of the original foundation. Does our answer of negative 60 make sense? No, it does not. We don't talk about the length and the width of an object in terms of a negative number, so we need to throw that one out. X equals positive 40, that's a viable option for the length or the width of a rectangle, so that's a good answer. Next, we want to make sure that we've answered the question. So let's go back and reread what the question is. They want to know what the area of the original square foundation is. Well, the area of our original square foundation using length times width is going to be x times x. We've established that x is equal to 40, so that area is going to be 40 times 40, which is 1,600. And lastly, we want to include any necessary units. Our unit here, since its area, would be feet squared. Jennifer's original foundation had an area of 1,600 square feet.